So I won't go through all of the updates in the latest release. I'll just briefly mention them. The release notes are available on the website. Here, maybe I'll just mention the axis calculator, where we can validate and project points onto the axis for validation purposes. We can now export points in DXF format and also in line string, which was a requirement for many customers. We've also improvements to the 3D overview, the visualization. Now we can zoom in and get very close to the design without it going out of view. For Amberg Profile, I'll show this, jump across to the software in a minute and show you this. We have now a DXF export, which is very similar in appearance to the existing PDF export. So it exports with the attribute information alongside the actual profile and the measured profile. And then the matrix DXF, of course, there was a requirement to have the profiles side by side in a matrix or a grid format. I'll show you that too. And then in Amberg Tunnel Scan, one of the main ones is we can filter points by distance from the design now. So this is quite a convenient and easy way to remove noise from the middle of the tunnel, such as people and machines that were picked up from the laser scanner. We can also, when we look at the checkerboard repositioning, which is the main focus of this webinar, we can also include geotechnical points as part of the control point network as well, which is often a requirement in the tunnel. We have a direct import of RTC with a dialog where we can select the multiple setups and import RTC data in its native format directly into Amberg Tunnel Office. And then, of course, getting on to the main topic, which is the positioning of the scanner with black and white targets. And we also have support for the latest RT360 firmware, which was recently released. There's one other notable update, which is we have an advanced workflow for the total station setup position. So I will show you that now. So with the advanced workflow, typically you would go into the instrument position and you would select the tripod task, measure without names 3 points, and it will produce the results. Sometimes, depending on your control network, on rare occasions, when it does a resection, it sometimes can find 2 valid results in 2 different parts of the tunnel because the distribution of the points for your measured points are so similar. There are 2 valid solutions. So now we have a workflow for dealing with this scenario. So you would select the tripod task, normal workflow, it will check the instrument level, you would level it if required. You would measure the first target point, the second target point, and the third one. Then it will usually give you your result. And most often it's just one result. But now we have this option where if it finds multiple possible solutions, it will tell you. And when you advance to the next screen, you can either measure an additional point, which will often reduce the solutions to 1 valid solution, or you select the control point list that you measured. So, so the assumption here is that you would know what control points you measured approximately. So in my case here, it's F1, F4, F5. The names above that are just names I made up. And then, of course, it will tell you where the total station is positioned approximately in the tunnel. Usually you would know approximately where you are in the tunnel in terms of heading station. And that's it. Then you are ready to proceed. So with the black and white positioning, the normal workflow is of course, the APM, the Amberg positioning method, where we would use the total station to position first and foremost, to position itself. and then to position the scanner in absolute coordinates in your tunnel coordinate system, which would then give us the ability to measure measurements versus design for volume calculations and overbreak and underbreak and so on. So normal workflow, you would set up and level the instrument and then control it from the tablet. Typically, you would measure the prisms, which are the Leica standard prisms, which are mounted in the tunnel. And then you would measure the instrument, the scanner position itself using the APM, Amberg Positioning Method accessories. Now, with the black and white, we do not need the total station to be present at the same time. So the total station crew can be working on a different time schedule and establishing control in the tunnel. So you do not need this instrument to be part of the setup. And instead of the Leica prisms, you would simply clip on the black and white targets. And then therefore all you need in the tunnel is the scanner and the Navigator tablet and the black and white targets to clip onto the control points. So this is a plan view, so some considerations for black and white positioning. So this is a plan view of the tunnel. So here we have the tunnel face with the total stations, or sorry, the scanner set up on a tripod in the middle. This is actually just a sketch of the one of the tunnel test galleries we have in VSH. We have a test gallery here in Switzerland, which we use, and this is an approximate sketch of that. So we have the scanner in the middle, and we want to have our black and white targets, ideally 3 or more. We need 3 minimum, but all 4 is better for sure, but 3 at least. So a minimum of 3 control points. And ideally, for best practice, we want these control points surrounding the total or the scanner as much as possible. We want good geometry and a good solution for this resection results for best accuracy. So if we have, we're going to have good distribution if we can manage to have these black and white targets on both sides of the tunnel wall on the left and right. And we want to also consider the distance from the scanner to the black and white targets. This will depend on a number of factors, such as the actual distance, because what we're trying to do here is to make sure that the black and white target is detectable. If it's too far away and we're using a low resolution, maybe not enough points are falling on the black and white target for it to be detected. Other considerations, as I mentioned, are the angle of incidence of the scan data to the surface of the black and white target, also the quality of the target, and so on. Yes, so you simply would select the points parameters that you want to remove, and then delete the point selection and save the editor. And before I go to the black and white targets, I will just briefly show you the filtering tool we have in the tunnel scan editor. So this is the demo project, which is available on the website, and you can download it and you can get a trial license and you can explore all of the options. We have quite a comprehensive list of analysis, profiling analysis, scanning analysis, geotechnic analysis, and so on. So here in the point cloud editor for one of the tubes I have here, I've got a number of point clouds. If I open up one of the point clouds, the editor will open, and here we have a scan, and we have some noise, looks like some people in the middle. We now have in the filtering options a new filter which we can filter based on distance from the theoretical profile. So we can filter inside or filter outside, and then we can inverse the selection depending on what we selected here. So I will select the filter points inside, 0.5 meters, and we can change this value. And what it's done here, as you can see here, the distance 0.5 to the theoretical profile, and we can remove all of this information. The reason it's removing the floor in this particular scenario is because if I quickly go to the theoretical profile, this is actually the shape of the profile. So the scan finishes here, therefore it's greater than half a meter to the profile, and that's why it's removing that. The second one I wanted to show you is the matrix, the DXF matrix. I will open one of the profiling tasks for this, maybe this one here. So this DXF export in matrix format is available in the profiling tasks. So here we have a measured versus design profile analysis. If I zoom in, yeah, it's showing the measurements versus design, and very little overbreak and underbreak in this scenario. I can select a number of profiles here on the left-hand side, and then choose the DXF option. Now, in this usual DXF export dialog, we now have the option to export profiles in a matrix in the 2D format. So I'll go ahead and export that. I will save it to my desktop. I'll just create a name. So now if I go to the desktop and open up the DXF in a Autodesk viewer. Yeah, okay, here we are. Okay, so it's finally open. So those selected profiles are now here in the matrix format. Of course, we can always come to the layers, and the data is organized per layer. So we can turn off, for example, the information. We can turn off the deviation labels and so on. So everything is organized into layers in this way. I just need to right-click on the task and the relevant construction stage and choose Add Task. I'll choose one of the scanning tasks. I'll choose Blast Round Scan again. We could choose Line Scan or Layer Thickness Scan. I'll choose Blast Round Scan. I'll just give it a name. I'll call it the same name as the task type, but you can call it anything. And here we just need to define the some settings, very straightforward. For example, the scan resolution. I find with the RTC, the low setting is more than sufficient for the type of data we want to capture. The step size. This step size is how frequently the software will extract profiles from the scan data directly in the tunnel. It'll also sets the resolution of the 2D map, which I'll show, the color map. I'm going to set that to 0.1. And now we have our positioning method. I will choose black and white, of course. And we can choose the different color maps. So the points that deviate from the theoretical profile, we can color code them as you wish according to your specifications. You can also save the color map and import it and export it so that it's consistent across your project. for the different tubes and shafts and so on. So that's essentially it. There's very little to the setup. You can see here the project is in an unsafe state. I'll save it, and that is it. Now we have a task defined, and we will send it to the Amberg Navigator. So to do that, I'll go to the top node of the project tree and export to Amberg Navigator Tablet. The settings, but once we have the tasks selected, press play, and we just need to start the scan. So I'm using the emulator here, but it's using the real data. So we have saved maybe 26 seconds for a low resolution scan on the RTC. Once that scan is complete, it does this process now. So it's transferring the scan over Wi-Fi from the scanner to the tablet. And this can, the time it takes is maybe 30 seconds for a low resolution. It depends also if you're capturing images. But once it has transferred, it will then convert the scan to its own internal format, and it will start detecting the targets. So you are presented then with this screen. So here we just simply need to verify the automatic target detection. So we need a minimum to verify a minimum of 3 to position the scan into the tunnel coordinate system. So the software here has found one of them. Yeah, we can validate that one. This one also is good, and this one is good. And okay, so we found 3 targets. There was 4 targets, so we'll take a look at that later in the software to see why it didn't find that target. So it found 3 targets. We have validated them, and we can simply accept this now to proceed. If you wanted to go back, you can select this button here, and you can revalidate the target. So if I select this one is okay, let's say, for example, this one I put as not okay, and then this one is okay. Now we don't have enough targets because we need a minimum of 3. So I will go back, I will select the 3 of them. I know that 3 of them are good. It hasn't detected some anomaly or some sort of outlier, for example. 3 targets verified. I will proceed now. So now it is moving the scan from its default 000 coordinates to the tunnel coordinate system, which are approximately 5,000, 10,000 in easting and northing. So now it will, it needs to do 1 or 2 more things to present the data. It creates these evaluation tiles, and then it down samples the data for visualization purposes. So this may take 20 or 30 seconds also to do. So yeah, we have the near real-time results within minutes from start to finish, I would say. So it's processing now. I'm using the emulator, and it is the fan on my computer has suddenly started making noise. But usually the specs of the tablet are 8 gigabytes of RAM is more than sufficient for this task. Okay, so now we have the results, and without the use of the total station, now we can do measurements versus design. So here we have the profile shape, and here we have the currently selected point on the profile, which is this point here. And that point is 94 centimeters of underbreak. So what it does here is it's captured some points at the quite far away from where I actually wanted to evaluate the data. So what I tend to do when we get to this point is to go straight to the 2D map view, which is here. And now we can see the results. So this is a 2D flattened view of the tunnel. So if we look here, if we consider that the axis is in the middle of the tunnel, it's essentially flattening or de-rolling or unrolling the tunnel into a flat tunnel. So essentially the left and right side of this map are where the tunnel would, if you were to join it back together, would meet. So if I select here, for example, we have 60 meters that corresponds to this zone here. So what I tend to do is select the area of interest in the 2D map, go back to the profile view, and here we can see that this corresponds to this point here, which is this location view here corresponds to here. So we have over 1 meter of a overbreak here. Of course, we can use the forwards and backwards arrows to navigate. We can also tap with your finger on the touch screen to view. So here we have 27 centimeters of underbreak, and here on the floor we have 66 centimeters of underbreak as well. So using a combination of the 2D map view, let's see what, for example, here, this area here, if I go back here to the map, yeah, it's selected at this point here, which is the little area outside of the theoretical profile. So this color scheme, which corresponds to this scheme here, is what we saw in the task configuration. So you can define your own colors and your own color ranges, the color bands, for example. If I go to the 3D view, this also can be quite useful sometimes. It will load up the 3D view of the scene, which you can with the touch screen move and pan and look. I'm using my mouse, so it's a little bit more difficult to view. A little bit of a delay. Yeah, here we are. So you can, with the touch screen, you can visually see the tunnel, and you can see here that this area here is the overbreak, and the red is the underbreak, and so on. With the exported file, I would simply return to the Amberg Navigator Tunnel project and import the data. So to do that, I'll go to the top of the project tree, import from Amberg Navigator Tablet. I'll browse to where we have the file, this one here, and open. Because normally when we import from Amberg Navigator, we have a dialog giving a preview of what has been imported. Because I'm using the emulator, that dialog doesn't show, but that's a small issue with my emulator. But in the normal workflow, you would have a dialog. So the data has imported. Now, if I go down to the point cloud editor, here we can see now that we have a scan here, and we can see here that the scan is positioned on the axis in the axis coordinate system. If I open up the scan to have a quick look at it visually, this is it. So this is we can of course go to the axis point and attach a camera to the axis and look into the tunnel. Of course, normally you might use these filtering tools to remove and tidy up the scan if you want. Personally, I tend to use the filtering tools less because we have such capabilities also in the analysis. So I tend to leave the this information. Well, I might remove this part, for example, but I will leave this for the moment and close down this. And yeah, I'll close down this now as well. So now that we have the point cloud here, we might want to produce reports. So if I go to the analysis and right click and add a profile, add a point cloud analysis, because we're dealing with a point cloud, I will just call it S for scan analysis, and I'll do measured versus design. And in the wizard, I just need to, basically accepting all the default values here. We're just specifying where the data is stored. We only have one construction stage, so it's there. So I'm going to hit next and next. The point cloud sampling. This is the sampling resolution. By default, it's at 5 centimeters. I will just change it to 1 because it speeds up the processing. And of course, we can filter points inside or outside of the model. So I'll hit finish now. And over here on the left-hand side, we have these gray boxes. This means that there's data there that has not been processed yet. So to process the data, right-click and process all. Here we have the status of the processing. So yeah, it did it very quickly. I set the resolution to 0.1. I think if I set the resolution to 5 centimeters, that would have maybe taken twice as long. So this is again the D-roll view. We can click on the map and we can see the same experience that we saw in the tunnel. So we have we can click anywhere on the D-roll view and see the corresponding values here. This visually looks a little bit different to what we saw on the tablet, but we can correct that or tidy this up by going to settings and color map and updating the color map to match what we saw on Navigator if you want consistency. So from here then, of course, you can, I will save this project. From here, you can export, for example, a graphical report of the overbreak and underbreak, such as this one here. And you have different options for configuring how it will be cropped and fit to the page. We have the D-roll values here and the stationing values here. We can also export volumes of overbreak and underbreak and so on directly from here as well. But what I'll do now is we can also export, if we want a traditional profile type of exports, profiles at fixed stationing values, we can export profiles directly from this into the profile editor. So I will do that real quickly. To do that, click and choose export profiles. You want to choose what construction stage to export the profiles into. I only have one construction stage, so I will choose that. And I will choose, for example, to export profiles for the full range at 1 meter intervals. So every meter in stationing value, we will extract the profile. And because we're dealing with a point cloud, there's going to be a lot of points on the profile, so we can reduce the size and tidy it up with this filtering tool. We can put a number of points on the profile or a fixed spacing. I'll choose this fixed spacing of 10 centimeters. I think is more than enough. We can put in some attribute information. Maybe I'll just put in the operator, my initials, for example, and so on. And now those points profiles have been exported. I will save the project. Now, if I go to the measured profiles editor, we can see the profiles that I extracted. At the beginning, we've got a lot of outliers here. That's because of the, if I return here to the point cloud and open the editor real quick, it's extracting, trying to extract profiles here. So I know that I don't want that. So I can go to the editor and I can, maybe go down as far as where data is meaningful, so I can select all of this data and delete. And now we have the profiles here. Now that we have profiles in the profile editor, we can come back to the analysis and create a profile analysis. I will call it P for profile, and measure versus design again. And again, I'm basically accepting the default values here. And now we have the analysis. We can see here that there's some outliers. We can always clean the profiles as well using the various tools. And when we edit the data here, we're editing the source data as well. So it's not specific just to this analysis. Once I hit save, which I'll do now, that source data is updated and cleaned. And of course, from here we can export the usual reports and so on. And quickly show you, so this is the data that came in directly from Amberg Navigator Tablet. We can, of course, import the data directly from the RTC as well. So to do that, I will right-click and choose Import. And here we can import data from various different sensors and file types, like industry standard E57, LAS, we have the FARO and so on. Now we have the Leica RTC 360, so this will import the RTC specific data directly from the USB drive. So I'll select that. On the desktop here, I have the original scan, and this is directly from the USB. So I will select that folder. It sees that we have two setups. I will just select one of them. Of course, I could select both. Now I will import this directly into Amberg Tunnel. This data, of course, is not going to be registered. It's going to be in its no coordinate system, and we can use the black and white positioning method inside Amberg Tunnel to position the scan, just like we did more or less in Amberg Navigator. So it can take a few minutes to import. And now the data is imported, so I will save. And we can see here that the scan is not on the axis because it doesn't have a coordinate system yet. We can see here by the stationing value, we don't have a stationing value. So we simply need to right click and we can choose the manual picking of black and white targets or the automatic positioning. So I will choose automatic and next. And as long as we have the control points in the control point list, which we have, it will find them and identify them. So it has found these targets, P4, P1, P2. It didn't find this one. We can see here that there's noise and there was actually shotcrete and concrete on this target. So there's digital noise here and it was quite far away from the scanner. So it didn't find this one automatically. But of course, we can use the manual option to manually pick this point. But I have three points. I will hit next. And here are the registration results. Down here in the bottom, we can see the old values. The total station the scanner was at easting, northing, and heights at 0, and it's moving to the tunnel coordinate system of 5,000, 10,000. And we can see the results of this resection: 1 mil, 1 mil, and 2 mil. So I'm happy with that. If we have more control points here, for example, we could disable one that's causing bad results, for example. But we have 3 minimum, so we have to use the 3. So now it is processing the scan. And now we can see here that we now have the scan registered in the coordinate system. Now this scan is available for analysis in Amberg Tunnel. If I open the scan here, yeah, we have it positioned in the coordinate system.